Hello dear students. Now today we are going to start with the next topic of unit 3, that is error function. Now basically error function of x is denoted by the symbol ERF of, okay, and the definition of error function of x is equal to 2 upon root pi integral 0 to x e to the power minus u square du. The definition is very important. Remember, whenever we are finding out error function of x, your limit will be 0 to x. Okay. Suppose we are finding out error function of y, then your limit will be 0 to y. Okay. So please note that. So definition of error function, again I'll repeat, it will be 2 upon root pi. It will be always there. Integration is from 0 to x e to the power minus u square du. Now since it is a definite integration, whether you are having u over here or t over there, it doesn't matter. You can have any variable over there, right? Now one more definition that you are supposed to remember in an error function, that is complementary error function. The complementary error function is denoted by ERF of x, and in the suffix we are going to write down c. That c denotes the complementary. And the definition is like this. It is exactly same as the error function. It will be 2 upon root pi integration from x to infinity e to the power minus u square du. Now if you want to define complementary error function of y, how it look like? It will be 2 upon root pi, and here you are going to have y to infinity, okay, e to the power minus u square du. Fine. So these are the two important definition in the error function, and the whole topic is based on these two units only. Okay. Now let us see some properties of error function and the problems that we are going to solve, that are mainly depend on these properties. Okay. So first and the very important properties of error function is error function of infinity is equal to 1. So simply if you want to find out the error function of infinity, we are going to put here x is equal to infinity. Okay. Now when you put x is equal to infinity, you are going to have the definition of error function of infinity is 2 upon root pi, 0 to infinity will be there. Okay. And when you make use of gamma function, like when you put u square is equal to t, and when you use gamma function over there, you are going to get the value of error function of infinity. And the error function of infinity, as I mentioned over here, it is equal to 1. So please remember that error function of infinity is 1. This is a very important property of error function. Okay. Then the next is error function of 0. Now again in the definition, if you put error function of 0, so it will look like 2 upon root pi 0 to 0 e to the power minus u square du. And if you are having both the limits as same, the answer will be 0. That's why error function of 0 is 0. This is a very important property again. Error function of 0 is 0. Again by definition we can easily prove it. Okay. Now the next property is also important. Error function of x plus complementary error function of x. So if you add these two definitions of error and complementary error, what you are going to have, 2 upon root pi will be common. So 2 upon root pi over here, 2 upon root pi, that will be common to both. And when you add this part, you are going to have two limits, 0 to x and x to infinity. So when you combine it, you are going to have the limits from 0 to infinity. And that will give you what? That will give you the error function of infinity, fine. So error function of x plus complementary error function is equal to error function of infinity. And error function of infinity already we have seen in property number 1, it is 1. Therefore, error function of x plus complementary error function will give you 1. This is very important property of error function. Okay. Now let's move to the next property. Error function is an odd function. So I hope all of you know what is the definition of odd function. So whenever you are going to have f of minus x is equal to minus of f of x, then you are going to have that function will be odd. So since we are having error function is an odd function, it will give you that error function of minus x is equal to minus of error function of x. We are going to see the proof of this when we are going to solve the example on error function. Now again, the next property is very important. Already we have seen the error function of 0. Now we are going to see complementary error function of 0. And we know the relation between complementary and the error function. The addition of error and the complementary error function is 1. So can I write down complementary error function as 1 minus error function of infinity? But error function of infinity is 1. So it will give you 1 minus 1, which is equal to 0. Right? So if you have the properties of error function, you can easily apply it on a complementary error function with the help of the formula that error function of x plus complementary error function of x is equal to 1. And you can find out any values for complementary error function. Okay. Now similarly, complementary error function of infinity will be what? It will be 1 minus error function of infinity. So it will give you 0. Complementary error function of 0 is 1 minus error function of 0. That will give you 1. Now error function of minus infinity, if you want to find out, so it will give, it is equal to what? Minus of error function of infinity, because error function is an odd function, right? So it will give you minus of 1 by property number 4. Now this 8 property is very important, and we are going to see the proof of this while solving the problems on error function. So what is the property? Complementary error function of minus x plus complementary error function of x is equal to 2. Simply with the help of property number 3 and 4, we can easily prove this thing. Fine. Now the next important property is derivative of error function of x. So again, to find out the derivative of error function of x, we need do as second rule. And in the example, we are going to see how to prove it. But I'll just give you the simple trick. With the help of that, you can easily remember the error function of derivative of error function of x. So the derivative of error function of x, how to remember it? See, this 2 upon root pi is always there. What you have to do is simply e to the power, whatever number you are having over here, you have to take the square of it. So it is e to the power minus x square, and in the next term take the derivative of this thing, that x. The derivative of x is equal to 1. That's why I am not writing on anything over there. It will be 1. So you are going to have the derivative of error function of x as 2 upon root pi e to the power minus of this number square of it into derivative of it. Okay, let's see one more derivative. For example, if you want to find out derivative of error function of ax, how it is equal to? It will be 2 upon root pi e to the power minus and the square of it. That's why it is a square x square into the derivative of it. That's why it will give you x. Right? Now if you want to find out the derivative of complementary error function of x, so how it will be? It will be derivative of 1 minus error function of ax, right? This is by the property. And then derivative of 1 will be 0, and the derivative, this is minus derivative of error function of ax. So already we have seen the derivative of error function of x. How to remember it? It will be 2 upon root pi e to the power square of this thing into the derivative of it. So it will be minus 2 upon root pi e to the power minus a square x square into a, right? So the next property is error function of x is equal to 2 upon root pi x minus x cubed by 3 plus x to the power 5 by 10 minus x to the power 7 by 42 and so on. So this is the series expansion of error function of x. So how to prove this? So if you want to prove the, if you want to write down the expansion of the error function of x, you have to make use of the basic definition and make use of the expansion of e raised to x. So expansion of e raised to x is 1 plus x upon 1 factorial plus x square upon 2 factorial plus x cube upon 3 factorial and so on. So instead of x, if you simply put there minus u square, and when you expand it, you are going to get the expansion of error function of x. Okay. Then the 13th property is also easy. Integral 0 to t error function of x plus complementary error function of x dx. This is equal to what? Simply integral 0 to 1, and since this value will be 1, we are going to get the integration as x, and then you put the upper and the lower limit, you are going to get the answer as t. Okay. Now in the 14th property, I just want to explain you, whenever you want to find out the integration of error function of x, what you have to do is integral 0 to t, and if you remember the logic of log, the same kind of logic we are going to use over here. So we are going to write down that error function of x as 1 into error function of x, and then we are going to apply bipart rule over there. But while applying the bipart rule, you have to take care that you are going to take this as u and this as v. Now why we are taking error function of x as u? Because we know the derivative of it, how to find out the derivative, and the integration of 1 will be easy. So with the help of bipart rule, we are going to find out the integration of error function of x. Okay, so that's it for error function, basic of error function. In the next lecture, we are going to see how to solve the examples of error function of x. Thank you.